Hi, this is Neil Neslucin, Vice President of Sales and Marketing at MultiPhy. Today we'd like to do a short presentation on 80-kilometer point-to-point transport. Why is it so important, and how can one do it well at 100 gig? Okay, let's define the 80-kilometer market. Simply put, it's the network that runs around a large metropolitan center. I showed San Francisco Bay, but it could be any large city throughout the world: Shanghai, Tokyo, London, Munich, New York City. And what's stressing this network right now is the Content Delivery Network service, the CDN networks, which allow you to access the stuff that you want to see in the internet in a relatively localized fashion, thus preserving your internet experience. They're really stressing the metro infrastructure. Now, all these data centers are built approximately 80 kilometers apart, or I should say up to 80 kilometers apart. Not all of them go exactly at 80 kilometers. Many are a little shorter depending on where they're put, obviously. But they all standardize on that 80-kilometer link. And they act as one logical data center. So consequently, the bandwidth needs between these data centers as they're put around the city are huge. Now, how do we know that this is an increasing marketplace? We're watching the 80-kilometer 10 gig XFP volumes go through the roof, and many of those are being shipped right into this kind of application. What kind of platforms are prevalent? Certainly thin WDM muxes, but also the carrier Ethernet switch router, which is the combination of a carrier Ethernet box with a WDM front end, is becoming the prevalent platform in this structure. Now, every one of those CESRs demands a pluggable solution. Pluggability is key to those boxes for serviceability issues. Now, an important aspect of this marketplace is spectral efficiency. When you've got 10 gig clients plugging into these boxes, to transport those 10 gig clients across 10 gig lambdas, not a problem. When you've got 100 gig clients plugging in, one has to question whether it's appropriate to transport them across 10 gig lambdas moving forward. All right, let's think about the two big challenges in trying to build one of these 80-kilometer modules. The first is just to get to that reach, and the second is, of course, being spectrally efficient. If we look at the candidates that might get deployed for this, let's consider the existing IEEE modules, the 4x25 gig modules that are being deployed within the data centers. Are they spectrally efficient? Yes. 25 gig per lambda, very spectrally efficient. However, they are not spec'd, and they will probably never get spec'd to get to the 80-kilometer reach. The existing 10 by 10 gig solutions that are being deployed, they certainly can do the 80-kilometer reach, but they don't have nearly the spectral efficiency that the IEEE solution has. What we're proposing is the best of both worlds. We can absolutely get to 80 kilometers, and we have the same spectral efficiency as the IEEE standard. Now, what we don't show on this page is coherent, and frankly, it's not really even in consideration. The power and cost of coherent, at least in this generation, is much, much too high to be considered for an 80-kilometer link. Okay, so now we're showing the performance of our solution, and we're showing about 5 dB of margin at 80 kilometers at an OSNR of minus 20 dB, which is about where people run metro networks. And this solution absolutely gives you the long-reach 80-kilometer transport, very spectrally efficient, 4 lambdas for 100 gig, very, very low cost, and also the pluggability is a key factor in these platforms moving forward. We'd love to invite you to come and talk to us about the solution. We can give you a lot more details on it. And on the next page, you can see my contact information. I want to thank you for listening. Again, this is Neil Neslucin, Vice President of Sales and Marketing at MultiPhy. You can reach me at neil@multi-phy.com or call me at +1 978 302 5700. We look forward to your inquiries on this 80-kilometer module solution.